today our goal is going to be to continue to work with rotation, but what we want to understand is about how rotations will affect our coordinate points. There is a little system of a trick that's going to help us. Now, the first thing I want to do is I'm going to put up here on my board my little coordinate plane. And when I look at these, we have our 4 sections. Our top right one is our first quadrant. Then it goes quadrant 2, quadrant 3, and quadrant 4. Okay, when we discuss our x and y axis, our x and y coordinates, not axis, our coordinate points. In coordinate, or quadrant 1, they are a positive and a positive. Thank you. So we have a positive, positive. What do we have in quadrant 2? Good. Our x coordinate is negative. Our y coordinate is a positive. Okay, what about quadrant 3? Brett, have your planner out. I'll be coming around in a second. What about quadrant 3? It's a negative and a negative. And in quadrant 4, positive, negative. All right. We are going to follow directions on here. It says, Harrison, focusing up here so I don't have to mark you out. Rotating a figure in a coordinate plane. The vertices of a trapezoid are W, -4, 2. So let's go ahead and do this right now. I'm going to put W at -4, 2. -4, 2. -3, 4. -1, 4. And -1, 2. W, X, Y, and Z. That is what I should be seeing you guys making right now on our first example. Okay, we want to rotate a trapezoid 180 degrees. Now, on Tuesday we talked, if I rotate, I'm not going to stop anymore. Have your planner on ready. Next time I just walk around and I mark you down. We talked on Tuesday that when we do one turn, where if I started here and I rotated over here, this is 90 degrees. When we turn it so our X and Y coordinates switch places, so it's just like I'm turning a key. This turns to here. This is a 90-degree turn. When we do from here, we turn a second time. Still a 90 degree. And you're getting to the next point I'm going to say. Each time, each turn that we are focusing on is 90 degrees. Now, someone said 180. Yeah. So, like, if any of you guys did, like, skateboarding or dance or at the pool and you guys did tricks, you know that if I was facing one way but I went halfway around, we call that a 180. Well, a 180 is 90 plus 90. So that is what we are going to use. We're going to use that understanding. Here's what I want you to follow along with me on. Take your transparency paper, and we're going to put it right over the top of this. And we're going to always mark where your coordinate or your X and Y axis are. Do it really carefully. And I need you to trace our trapezoid. This tracing paper is really helping us. Okay, so I've traced mine. I'm going to be looking. I should be seeing everyone trace theirs. The instructions say rotate the trapezoid 180 degrees around the origin. That is an important concept. It's telling us our central rotation part is the origin, so at 0, 0. So it's kind of like if I put a thumbtack right here at 0, 0. When I rotate this paper, it's going to spin right around that origin. Gentlemen, focus on me, not other people that come in for a safe seat. So, when I rotate 180 degrees, how many turns is that going to be? So, this is turn. Watch how we change this. Here is my starting y-axis. One turn is 90 degrees. 2 turns. If I line everything up, now, what you need to be doing is we now need to write down what our new coordinates are. So, look at yours, and who can tell me what is the coordinates for W? Dusty? No. Where is W? Donovan? So W's here. You do your x-axis first. So we went over 4, and it went down 2. 4, -2. Where is x coordinates? Cheyenne? 3, -4. How about y? 1, -4. And z? 1, -2. Okay. I need to pop this over there. Alright, so I'm going to go back to my OneNote so we can keep this in there so if you have any notes. But tell me, what were they again? 4, -2. 3, -4. Alright. Now. Okay. Before I go on, we're going to do another example before we really dive into this. But Harrison started noticing something. And I'm going to just give you a hint. We were here. I was at -4, 2. That was W. And then I was at -3, 4. -1, 4. -1, 2. Okay. So I was, in which quadrant was I located in the beginning? I was in quadrant 2, which you guys told me means x should be negative and y would be positive. When we did 2 turns, we did an even 2 turns, that put us over here in quadrant 4. And in quadrant 4, we would have positive, negative. Now pay attention to this. There's a reason I'm saying this. I'm not just giving you facts because they're fun. Well, they are kind of. But if you think about this, what do you see the relationship between our 2 coordinate points right now? When I look at my original compared to my new, what do you notice? There's 2 important facts I need. Haley?
The same numbers, and then if one of them is negative, then it switches to positive.
Okay, close. Not just because it switches, but here's the important thing. First thing, if I did 2 turns, this is going to be important. If you do 2 turns, Or if you do 4 turns, I'm going to write this down. 2 or 4 turns. Which, if we go 180 degrees or 360 degrees, X, that'd be Y, X and Y become X and Y. You don't change the order. We're going to leave them the same. So I had a -4. Just look at the number. I had a 4 and a 2. I'm going to put a 4 and a 2. I had a 3 and a 4. I'm going to put a 3 and a 4. I had a 1 and a 4. I'm going to put 1, 4. 1, 2. I'm going to put 1, 2. Now what is important? This is the new concept. Look at quadrant. When I knew my original numbers were 4, 2, so I went ahead and I could just write down 4, 2, 3, 4, 1, 4, 1, 2. When I looked at what quadrant I was in, 2 turns would put me in quadrant 4. My x's had to be positive, my y's had to be negative. If I look at all this, positive, negative, positive, negative, positive, negative, positive, negative, that is going to be a way that we can have a surefire getting the right coordinates. Because transparency paper makes this easy to do our turns. You will not always have transparency paper. If I didn't have transparency paper, trying to rotate this might have been difficult. But if we use this knowledge, it becomes easy. So let's try this. On this first one, the vertices of the trapezoid are. So we're still at our exact same place. -4, 2. -3, 4. -1, 4. I think this is your second example, am I correct? Yeah, this is your second example on 2.3 rotation examples. Make sure you go down to the next one and start doing this. -1, 2. Can we do this without rotation paper? I think we're going to be able to. Let's look at this. It tells me I'm going to rotate 90 degrees. How many turns is 90 degrees? 1 turn. 1 turn. I'm going to write this note down for you guys. Oops, that's a line. But this is going to match up with this. If I do 1 or 3 turns, which is 90 or 270 degrees, my x and y are going to do what? Let's not say it yet. Use your transparency paper. Use your transparency paper. Actually, we already have it drawn, don't we? Yep. So let me go to mine. That'll make it easy. So if I'm on this one, should already have it drawn. -3, 4. I'll go ahead and do mine real quick. Okay. You told me 90 degrees is how many turns? So everyone should turn their paper like this. This is what's helping you. I'm trying to help you guys have a visual. This makes it easier. Everyone, when you turn, your trapezoid should be in quadrant what? 1. This is quadrant. Remember, top right is quadrant 1. So, what someone that has their transparency paper on them, What is the new coordinate for the W? Dusty?
Orchard.
No.
2, 4.
I don't think this is on this drum. W should be, let me check on mine. Good. Try it again. Dusty, look at yours again. Dusty, what do you think? Try it again. Where's W at? Remember, X is left and right. 2, 4. Yeah, you just said them backwards, buddy. So, let me use a bigger one. My coordinate is 2, 4. What is X? Huh? Nope. Look at your transparency paper again. Should be 4, 3. Make sure you're writing this down, guys. What's Y? Dylan, Kipper, focus up here for me. I want you guys participating. What should Y be? 4, 1. And what is Z? Okay. Now, one thing. One thing that I am noticing. Okay. Now, if you guys look at your transparency paper, make sure you're also writing down the labels for the coordinate points. That's where you guys made some mistakes. You guys were not doing that. So, make sure you write down those coordinate points. Now, look at this. What do you notice between just the numbers? W was 4, 2, now it's a 2, 4. What happened?
Shouldn't the 2 be? Oh, no.
They flipped. We flipped them. So the numbers end up switching. I don't know if that's the best way to write that. But we will say when X and Y numbers flip. The Y became the X value, the X became the Y. Brett, let's give me one, please. Okay, I'm going to give you a little bit, then I'm just going to send you another room, and then I'll have you company at lunch. You can make the choice. So, there's one part. Excuse me? What? What do you say? That's why I'm moving you so you're not talking to someone. Okay. So, the numbers flip. Then the other thing we have to look at is we have to look at the quadrant. What quadrant are we going into? When I did one term, we went into which quadrant? We went to quadrant 1. Quadrant 1's coordinates are positive, positive, which means my new quadrant points should be a positive, positive. Okay, we're going to take all this and put it together. And this should make this very simple now. If you paid attention and you're looking at this, without transparency paper, we are going to be able to do this next one together. And you're not going to have to use transparency paper. my goal is that you're going to be able to look at your coordinate points and you're going to be able to identify what the new ones will be. Here's how we're going to do it. So the next one is the next page in your notebook. Should look like this. Rotating a figure in a coordinate point. Okay, I am still using the exact same coordinate points.
Wait, it's supposed to be green.
Well, mine's green. Yours is probably white. I think we made the copy it's that way. So, I'm still going to put these points in there. -3, 4. -1, 4. -1, 2. Alright, without using our transparency paper, without actually drawing this yet. See, this is actually a shortcut to help you guys. If you paid attention to this, this will help you get the answer easier. It says, rotate it 270 degrees around the origin. Remember, key point is we are going around the origin. That's why this is working right now. Origin's in the middle. 270 degrees. How many turns is that? Okay, that's going to be our 3 turns. So I'm going to go 1, 2, 3. I'm going to end up in quadrant 3. Now, what is the rule when we do 3 turns? What will happen to our x and y coordinates? We just had this up here. What happens to our x and y coordinates? Hold on, not about the values. What do we do with the x and y numbers? What do we know with 3 turns? What am I going to do with my numbers? Do they stay 4, 2, or do they go 2, 4? They flip with 3 turns, 1 or 3, 90 or 270. We're going to flip our our coordinates. So instead of 4, 2, I'm going to say 2, 4. Instead of -3, 4, I'm going to say 4, 3. 4, 1. 2, 1. This is our new coordinates.
Did we make them negative?
Good. The second part. We are in quadrant 3. In quadrant 3, our x coordinates have to be positive or negative. Which one? Have to be negative. We're on the left side. Our y terms have to be 1 second. So all of my coordinates are now going to be negatives. -2, -4, -4, -3, -4, -1, -2, -1. This is very simple if we focus on it. I'm going to say it again. First, all you have to do is ask yourself, there's 2 questions that you have to answer in order to know what the coordinates are. And we'll check this in just a second. The 2 questions. The first question. Question 1. Number of turns. So what does that do to my x and y numbers? The second question that you ask is what quadrant How does that affect x and y value? Honestly, guys, today's work is really 2 steps to identify your coordinates. Every time you just have to ask yourself, okay, how many turns? If it's 1 or 3, 90 or 270 degrees, I'm going to flip the values. If x was a 4, y was a 2, it becomes a 2 and a 4. After you switch them, you just have to ask, what quadrant will I be in? When you identify that, in quadrant 3, x's are all negatives, y's are negatives. So my values are negative, negative. Let's see if we were right. If I go back to here, and I had my negative 4, 2 for w, my negative 3, 4 for x, negative 1, 4 for y, and negative 1, 2 for z. We lined this up. This should really be helping you in your homework today, being able to use tracing paper. I had to turn 270 degrees. That's 90, 180, 270. And then we match up, did our coordinates come out correct? And hopefully your answer is yes. W was negative 2, 4. Negative 2, 4. Or I'm sorry, negative 2, negative 4. X coordinate was negative 4, negative 3. Negative 4, negative 3. So, I'm not going to have to write this down. We kind of just discussed this. What patterns do you notice when you rotate 180 degrees? Remember, that is our 2 turns. When we did our 2 turns, x and y stayed the same. We did not flip the numbers. So I'm just going to say x, y stayed as x, y. Look at quadrant there. Rotate 90 degrees. X, Y, flip their numbers. With 270 degrees, that's our 3 turns. X, Y, flip numbers. So, right now, I'm going to give this up to us and see if we can do this. I'm going to give suckers for this one. So, here's my coordinates. I want you to be able to answer this. What are the coordinates for J, K, L, and N? And we're not using transparency paper. All we're going to do is think about where we're at. So there's going to be 2 steps. It says around the origin, that's important, that's our middle, 180 degrees. Jordan, how many turns is 180 degrees? Okay, 2. With 2 turns, what's going to happen to my x and y? Are they going to stay the same, or are they going to switch numbers? Thank you, Jordan. I love that you said that because I heard 2 people say switch, and you didn't follow with it. 2 turns. Stay the same. 2 turns, 180 degrees or 360. They stay the same. So, right now, I can tell my numbers are going to be 4, 4, 4, 2, 1, 0, 2, 3. The second thing we have to ask is what quadrant do we go into? if we look at this first one, it was -4, -4. So think about your quadrants. I was negative and negative. That means I was in this quadrant. If I do two terms, 1, 2, these are positive, positive. So all my coordinate points need to be positive. There will be no negatives.
Because in K, the 4 is already in the negative zone, and it's in the positive zone, which is twice.
Oh, because he wasn't in there? Hold on. Oh, because he went there. You're right. We'll look at that. They gave us a little trick off. We should be okay about this though. Here's what I want you guys to try. Okay, for your homework. I know, we're going to see something. It'll be okay. I'll explain it. There are one exception to this. And I'm sorry, that's totally on me. I should have made sure I point this out. And I like that Donovan caught it. But I'm going to make sure we understand it. Mm-hmm. Now, listen to this part. There is one exception to this. All the examples I was doing with you, all of our points were falling in the same one quadrant. The problem happens. This is where this rule still stays put. There's one thing that you had to do. On this one, let's look at this. This was in quadrant J. You're going to have to look at every vertex. J, 2 negatives, that means it was in quadrant 3. K is in which quadrant? If it was a -4, -2, that's in quadrant 2. L, -1, 0, it's just going to be on our line. And then M, -2, -3. This is the part, gentlemen, Harrison, I know you didn't need this. With 2 turns, we're going to go 2 other quadrants. So, this one, 2 turns, would have been our 1, 2. It needs to be now in quadrant 1. This one was in quadrant 2. 1, 2. It needs to be in quadrant 4. He is still going to just jump from here to here. It's going to be right on our line. And this one's quadrant 3 needs to go to quadrant 1. All you have to do is look at each one of your points and identify what quadrant each one is in, and that tells you your values of x and y. So, for homework, the bell's about to ring. You're doing lesson 2.3, day 2. We'll check in them all tomorrow.